Alright, we need to find out what to do, and every question is going to be different, so you're going to need to be able to determine what the question is trying to ask you. So we can see here that in question 2 we're either going... No, we're not either, we're doing both. We're finding the number of moles and we're finding the number of atoms in the samples. We have 14.6 grams of ethine, which has a chemical formula of C2H2. Fairly certain that the name of this over here is wrong. Should be that. And so the best place to start is to figure out where you're trying to go and what information you have. What we're trying to find out, and we want to use the symbols so that the formulas will be more apparent. Number of moles is using the letter N, lowercase n, and the number of atoms is capital N. And so we have two formulas at our disposal. We have number of moles is equal to the mass over the molar mass, capital M, and we have number of moles is also equal to the number of particles over the number of the number representing 1 mole, which is Avogadro's number, which is that symbol. Okay, so the information we do have that's being presented to us is the grams of the compound in question. We also have its chemical formula. So out of the variables, we only have mass. This is the only one we have. We know that we are trying to determine number of moles. We're also trying to find out the number of atoms present, but we don't have number of moles, and we also have Avogadro's number. So in order for us to find an answer in any of these, using our understanding of mathematics, we need to know everything, all the different variables, except for the one that you're trying to determine. So if we have just the one variable here, and we're trying to determine the number of moles, then we need to determine the molar mass in order for us to find any answers. We can't start here yet because we don't know the number of moles and we don't know the number of atoms either. So that's not enough information to determine the number of atoms, so we're going to do that after we can figure out the number of moles. So we'll do this first. Okay, so because we can calculate the molar mass of ethine, that's going to give us the first answer. So ethine is made of 2 carbons and 2 hydrogen atoms, and using our periodic table we know that carbon is 12.01 grams per mole, and hydrogen is 1.008 grams per mole. And so using those values we can determine the molar mass by doing 2 times 12.01 plus 2 times 1.008, and that is equal to Here we go. That's equal to 2 times 1 plus 2 times 1.008. Nope, that's not, that calculator use was wrong there. That's not the right number. Clear that. What did I do wrong? Brackets. I need brackets. Okay, so how about I'll just do it in my head. Nope. 2.016, which is 2 times 1.008, plus the 24.02. Okay, there you go. 26.036. Yep, cool. 26.036 grams per mole. Okay, now that we have that, we can now determine the number of moles of ethyne, and that will require the formula. So we go N equals to 14.6, because that's the mass over here. We're going to divide that by our molar mass of the compound in question, 26.036. That is equal to clear 14.6 divided by 26.036. That is equal to, oh come on calculator, where'd you go? 0.5607620, and we're going to do that to 3 significant figures. So 0.56076, 0.56076, 3 significant figures. I'll explain that another time. 0.561, because this is the third significant figure. Okay. Okay, so that's the number of moles of ethyne that we have. Now that we have the number of moles and we have Avogadro's number, we can now determine the number of atoms. However, it's important here that you understand that what we have just calculated is the number of moles of ethyne. So that's why using a subscript for our calculations is really important, so that we don't lose track. So we can say that because we have 0.561 moles of ethyne, and because there are 4 atoms, 2 carbon, 2 hydrogen, in in an ethyne, we can say that therefore the number of moles that we have here is going to be 4 times, let's call that total, 4 times 0.561. And that will be, clear that and go 4 times 0.561. That is equal to 2.244. 2.244 moles of atoms. I guess I could have used atoms instead of capital T, but that's all good. Alright, now that we have that, we can use this formula rearranged. So to rearrange it so that I can find out the number of particles present, in this case the number of atoms, we can rearrange it so that the formula looks like this: N times Na is equal to capital N, and so 2.244 6.244 times Avogadro's number, 6.02 times 10 to the 23, is equal to times 6.02. How do I do powers on this? Scientific? There we go. 2.244 times 6.02 to the... Nope, don't want that. This is why using your calculator and knowing how to use it is really important, and I'm using the computer one. It's super confusing. What if I do this? 6.02. Oh, I see what it's doing. Clear all. 6. Damn it. 23 is that way? Oh my gosh, how to do it that way? Times 6.02. You stupid calculator. 2.244. There we go, but that's not in scientific calculation. That's not scientific notation. That's not cool. Okay. I'm going to have to change the settings to that. Okay, so that will be equal to 1.351. No, how many significant figures are we doing? We're doing 3. 1.35. Yep. 1.35 times 10 to the power of how many of that? I've got 3, 6, 9, 12, 15, 18, 21, 24. Alright. Correct to 3 figures. Just very quickly, how do I know how many to do in terms of significant figures? It's based on the values that you're using in your calculations from the beginning, and you're looking at the value that has the least number of significant figures. So in the question, because it's given us 14.6 and that's 3 significant figures, that's the sort of level of precision that we're going to use for the rest of the calculations, and we'll explain why in a later time, but that's essentially how you do it.